Hello, everyone. So, in my last lecture, I covered some topics for AI and ML, which is basically machine learning and artificial intelligence. I covered some Gen AI, basics of Gen AI, and then where does deep learning fit in, and LLMs, which are large language models. So, why I am talking about AI ML in this channel is because Kubernetes is a very good platform that can be used to run AI ML workloads. So let's look at it. Why should we think about Kubernetes? So AI ML workloads, if you know, right, on the top layer I have the applications, which is your Gen AI apps and your machine learning apps, your LLMs, which are basic big models. They could be workflows, batch jobs, and then find, and all this is stored in a big vector database. So when we talk about running these, definitely you need very high powerful power processors, like, so your compute has to be your AMIs that you use to build to run these have to be highly powerful. So, and also now while you're running these, why would Kubernetes fit in is because Kubernetes, one thing is it's cloud native. It's a lot of things have been automated. Your CI/CD pipelines can directly build and deploy. And other than that, it basically provides a lot of capabilities such as scalability, because what we all know, right, Kubernetes, it will allow to scale your workloads up and down based on the demand, uh, on a dynamic basis, because with lot of new features like Carpenter and others, it can all be done horizontal pod scaling, vertical scaling. It can be very good. Another thing is efficiency, right? It basically is basic, we all know, right, availability. It's always because of the orchestration, it's always available, highly available environment. And another thing is fault tolerance, because when you have self-healing capabilities, then when your workloads are down, the pipelines can, which are running are failing. In event of any failure, if it's fault tolerant, if it's self-healing, that's what you need, so that your applications are not affected. So basically, it's one of the key platforms which has been used and has been explored, and in KubeCon, as well as if you go to sessions in the reInvent, AWS reInvent, which just happened last week. There were a lot of talks about running AI ML workloads on Kubernetes. So that's why it's very important for us to just get a 101 basics initially, and then do deep dive as why would we talk about these two things together. So another thing is, like, if you look at it, right, what do you need on the compute? So when you build a Kubernetes cluster, you remember, right, you have a control plane, which if you're using AWS or Azure or Google, it's managed by them, but you have the node groups which are managed by you. And when you manage those node groups, you have the option to select the AMIs. When you're running these high, machine learning, deep learning workloads, you definitely need something which are very powerful. So like Amazon provides a lot of these, which are called, like, one of them is Graviton. And so basically it's called deep learning AMI. If you just go and check on AWS, basically they have a range of, they're calling DLAMI, which is deep learning AMIs. So you can select based on what your requirement is, and what your data is, and what's the format of the data, and what is your, how much power you need. So like, they have options, something called as Conda, DLMI Conda, and they also have Graviton is becoming very popular because it is very, it's x86 based, ARM based, and then it's basically, it runs very high, like, powerful. It's a processor, so basically it can run very high. It's a family of processors which can deliver very good performance because of, its high power. So another thing I have put over here is, you can also have other options based on your requirement. And so when you have a powerful compute, you also need good storage, because there is a lot of data involved in AIML, especially like all your data models and vector database. So Amazon provides like something Redshift, that's an option, like also RDS databases. Then of course S3 is the main choice, where underlying infrastructure, where it can store petabytes of data. So you need very huge, volume to be stored, and EFS is always an option. So all of these things together provide a very highly efficient, scalable, reliable, and secure architecture to run the AI/ML workloads. So let me share some of the sessions that I enjoyed during KubeCon. Also, everything is available on YouTube. So if you just Google, you will be go to YouTube, and if you search for KubeCon 2024 or KubeCon North America 2024 or KubeCon Europe 2024, you will see a lot of sessions. And then just I have pasted some of them. I'll provide this in the comment section so that you can click on it, and once you go to one of them, it will automatically keeps on bringing other sessions from the same conference. So these are the ones that I really enjoyed. So the first one is accelerating AI workloads with GPUs. So this is what I was initially talking. So basically running your workloads on GPUs. Then there was a keynote, build an open source platform for AI ML. There were another keynotes related to take a peek under the hood of native AI at scale, and then there was a good NVIDIA case study, which how they're delivering AI and how they're building all these intensive hardware and their core infrastructure that can be used to run AI/ML workloads. There are many other sessions. But some of them go into deep vector databases and how to take backups of vector databases. There was a session by VM team that was very good. So they talk about, because all of these, when they require databases, and how then you have to make sure once your data comes on Kubernetes, then it doesn't remain stateless, right? So then you have to manage and see how you can also manage data on Kubernetes, and then how do you manage backup and all. So there was a whole day, whole session, what do you call, like co-located event, which was called DOK, data on Kubernetes, where they discussed that. So if just search for that, and everything on that covers about how you put various workloads, databases, and then various strategies to build your based on your use case, you can decide which one works best for you.